Number 18 in 4.2 is asking us to find all the critical points of this function right here. F of x is equal to x squared times the square root of 1 minus x squared. So we're going to dive into that pretty directly here. The one thing I do want to point out ahead of time, though, guys, we are dealing with a function right here that involves a radical. This function is going to have a limited domain. There are certain x values for which you're not going to get a real y value out of this function. For example, if I put in something like 5, this would become the square root of 1 minus 25, which is negative 24. And of course, if we try to take the square root of negative numbers, we get an imaginary result. So if you look at this here, guys, the only way that we can get a positive or 0 result down here is if the x there is going to be a value in between negative 1 and 1. So our domain to this function is, and let's see, those values would work. So yeah, this would be brackets right here. All right. Anything outside of that domain, such as positive 5 or negative 3, is going to get you a non-real result. So when I go to find my critical points in a couple of minutes here, if I get any critical points that are not within this domain right here, I've got to throw them out because they don't actually exist. Okay. Let's make sure we understand something very basic. The definition of a critical point, everybody, a value for which your derivative is either equal to 0 or undefined. So we need to find f prime of x, and let's get to it. This is going to require the product rule. I probably should rewrite f of x before I dive in here, guys, as x squared and then multiplied by 1 minus x squared to the 1/2 power. All right, that's easier to deal with than the square root. So here we go now, guys, derivative. First factor is just x squared times the derivative of the second. That's more complicated. 1/2 times the same base, 1 minus x squared to the negative 1/2 power, times the derivative within, which is going to be a negative 2x. So there's our chain rule right there coming into play there. So that's first times derivative of the second, plus the second factor, 1 minus x squared to the 1/2, multiplied by the derivative of the first, which is going to be a 2x, and I'll put that out in front. Okay, so there's our derivative, and I definitely think it's worth our time and effort to try to clean this thing up a little bit. So what do I see here? In the first big term, I do see a 1/2 multiplied by a 2. So those will take care of each other, but be careful, that negative did not go away. So I see, let's see, we're going to have this here. There's going to be a negative. I see an x squared multiplied by an x. So that'll be the opposite of x cubed right there. And then on the bottom, a square root of 1 minus x squared. And let's see, I took care of that. I took care of this. The negative is still there. The x was dealt with. I think that's everything there. And then for the second fraction right here, yeah, not quite as nice here, guys. That's just going to be a plus 2x times the square root of 1 minus x squared. That's where we're at. And I'm going to do something now that I might not normally do. I think it would benefit us to get this derivative written as one term and one fraction. So I'm going to multiply the second term right here by this denominator over itself. Square root of 1 minus x squared over the square root of 1 minus x squared. That's going to get us a common denominator and allow us to put these two fractions together. So I think we can go right there. The common denominator will be the square root of 1 minus x squared. And in the numerator now, we're going to start with this negative x cubed out in front, and then when I move on to the second one, something cool happens right here. Didn't really intend that. This square root of 1 minus x squared times this square root of 1 minus x squared is just 1 minus x squared. The radicals are gone. So it's a plus 2x times 1 minus x squared. And I suppose while I'm there, yep, some stuff is going to happen to simplify that numerator when I distribute that 2x right there. So what I see here, guys, is that this times this is going to get us a negative 2x cubed. We'll put it together with that term as well to get a negative 3x cubed. And then this times this is just going to be 2x. So I'm going to make that a 2x minus a 3x cubed all over the square root of 1 minus x squared. Okay, so that's what I have for our derivative here in problem number 18. And now, with where we're going here, all right, the reason that I like my derivative written as one single fraction like that is that now when we start thinking about what's a critical point, we can break this up. I kind of like these rational derivatives, guys, where there's x's on the top and x's on the bottom. In order for this derivative to equal 0, that will happen anytime your numerator is 0. So I'm just going to set 2x minus 3x cubed equal to 0 and solve. But keep thinking now, guys, it's also possible you can have a critical point when your derivative is undefined. And an undefined derivative happens anytime that your denominator is 0. So the square root of 1 minus x squared could equal 0 as well. Okay, so we're going to solve each one of these independently. On the left, I'm going to, not much, I'm going to factor out an x, I guess, and be left with 2 minus 3x squared is equal to 0. That's all the factoring you can do. From here, we're going to get x equals 0 as a critical point, and then this one's going to be a little bit more complicated. If we set that equal to 0, we'll get 3x squared is equal to 2, x squared is equal to 2/3. X then will equal plus or minus the square root of 2/3, and there we go. Now, I warned you guys a while ago, the domain of this function is limited to everything between -1 and +1. Anything greater than 1 or less than -1, we're going to have to throw out there. But what do I know here, guys? Since 2/3 is less than 1, the square root of 2/3 is going to be less than 1. And then the opposite of the square root of 2/3 is going to be greater than -1. So both of these numbers are within, I should say all three of these numbers are within our domain, and we're good keeping all of those. And then over here on the right, a lot of you guys would just look at this and tell me what the answer is, and you're right. But algebraically, if we squared both sides, we'd get a 1 minus x squared equals 0. We'd get a 1 equals x squared. We'd take the square root here and the square root here, and we'd get x equals plus or minus 1. Now, are those numbers within the domain of our function? If you were to go back and plug a 1 in right here, right there, you'd end up taking the square root of 0, and because it's in the numerator, that's perfectly fine. You're going to get a real result out of that. And so, you guys, when the directions say find all critical points, I think we have them all right here, and I think we came up with a grand total of 5 for this problem right over here. Okay, all 5 of those values. I'm sorry, I'm reading the solutions manual right here. So we've got 0 plus or minus the square root of 2/3. Now they say the derivative does not exist when x is equal to plus or minus 1. Okay, now I see what they were going for right there. Let me slide this down just a little bit. I was right in what I said. These two values are in the derivative of the original function. But the derivative, before I messed it all up with this stuff right here, let me move that out of the way. The derivative was this right over here, and now, yep, I should have seen this, 1 cannot give you a valid result for the derivative when you plug it in here for x, because now that square root ends up in the denominator, and you end up with something over 0, which is undefined. So we've got to throw those two out, and we end up then with these 3 critical points for this function here in problem number 18.